Hello, everybody. I hope you are enjoying your snow day. I just wanted to go over this assignment here. You can find it over here under modules 2. And just a bit of advice if you are having trouble with this, I highly recommend you go over here. Try your readings, your chapter 2 readings, because hint, hint, nudge, nudge, wink, wink, some of them are already in there, right? Some of these problems I'm asking you to do might appear in the textbook. All right. So let's go back to our problems here. We've got 4 problems here. Each one is worth 25 points, but there's no reason why you shouldn't be able to do all of them. So the first one, we want to do these as 4 separate Python programs. First one is a chocolate weight program. The second is debugging. The third one is a very basic one that you'll see in basically every kind of intro to programming class, which is a temperature conversion. And this is one that we did very similar to what we did in class, converting seconds to hours. So if you need help with this one, refer back to what we did on Thursday, right? So the first one, Otaka does all I need. We're going to be using an older equation to calculate first the basal metabolic rate, or BMR. This is called the Harris-Benedict equation. I chose this old equation because it's rather easy in comparison to other ones, because it's just simply just doing order of operation. You've got height, weight, and age. You plug those values in, and you use the equation to generate the BMR. We're not going to be bothering asking if the person is a man or a woman or a boy or a girl. We don't ask that because we haven't learned how to do if statements. Okay, so we're just going to print out both. Okay, we're going to find it actually doesn't really change the difference much at all. So the formula. So the idea here is that we are going to be calculating if all I did was stay in bed and eat chocolate bar, living the dream as it were, right? Then how many chocolate bars would I need to eat to make sure I maintain my weight? So we're going to be taking in the weight, the height, age, and I'll show you a bit about how to do that in a second. Second one, we copy paste this in, get it working such that when the user enters 12, the output will be 139. Temperature, given Celsius, convert to Fahrenheit. I recommend doing 37. And then again, the input here should be 5,000 seconds. It doesn't have to look exactly like this as our output, but something where we are computing hours, minutes, and seconds. All right, so our first one, Harris-Benedict equation. So the first thing, this is the input compute output kind of paradigm that we kind of alluded to. Basically, we need to ask the user for 3 values, take those 3 values, and then plug them into the equation, right? So we can start in one of 2 places actually. We can start by taking the inputs from the user, or we can start by doing the calculation. Either way is a valid choice. I'm going to go ahead and assume that people want to go from the top to bottom, but the way you would do that otherwise is we would basically say, oh, I'm just going to assume my weight is equal to, let's go with 165 or whatever. Not my actual weight. I need to lose weight. That doesn't matter. You basically just, and then you would do height is equal to whatever, dot, 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 doesn't matter, right? And then you would do, basically you'd put in temporary terms, right? You'd make these things to do, replace with input. Notice that these are comments that I'm writing. Input. And then I swear I learned how to type it one of these. Okay, and then we're going to do BMR M, I'll call it, or maybe I'll do MBMR. There we go. MBMR is equal to, and then we start by just basically, we can try to copy this in, but notice that I went ahead and used the mathematical dot, so this might be a bit tricky, but we can see what happens if we copy this. Why not? Oh, not too bad, actually. Generally speaking, though, you'll learn that it's a bit risky to kind of copy stuff because the math sometimes is a bit weird, right? let's just go ahead and, oops, I replaced something there. That should be plus, right? Double check. Right, this is what happens when you type in, oh no, it's supposed to be minus. See, this is what happens when you type minus. What was there originally? Was it weird? No. There we go. So there, and what we're going to do is we're just going to plug, you know what, I'm going to plug in some nonsense values here, just to kind of get the idea across. -1, -1, height, weight, and age, -1. These are obviously incorrect values, but then what we can do is that we can print out MBMR, and basically we know that we've got a running program. It works, albeit incorrectly. I'm going to go and put this in my, let's go with documents here. Okay, we are going to go and do, I'm just going to call this BMR, or chalk, BMR, whatever. It doesn't matter what you call it. But here we got a answer. Yes, it's an incorrect answer, but now we know it's running without any errors, and that is a hugely important step. Okay, that is one way to do it. Right? And the reason you can do it this way is that you can do the what a lot of people do consider to be the scary part, the math, first. However, the other way that we can do this is just do it by basically saying, hey, how would I do this? We need to take in the weight, the height, and the age. So how do we take in a value from the user? We use the input function. You know what? Let's be informal today. Please enter how heavy in LBS. Right? It's fine to be funny. Just to know when you're not supposed to be funny. All right? Please enter how big you are. Okay, so basically we take these values, height, weight, and age. Please enter boldness. Okay, doesn't matter. I'm just being stupid right now. All right, and we've got these values, right? And we can double check that we got them by printing them. We can do them one at a time by printing one on each line, or we could just do print age, weight, height, age. It's a pain to use idle sometimes, but it's at the beginning. So here we go. It's fine right now. 70, 70, and 70, right? That's fine. Let's go ahead and get these to be a bit more. Let's add some spaces between them so the input looks nicer. 1, 2, 3. There we go. Now what we're going to do here is a lot of students, what they'll think about doing is we're going to just directly put this into our equation, MBR, basal metabolic rate, is equal to, and then we use the equation that we got over here, and we try to put this in. Oops. So let's clean that up. No dots, right? Just replace those dots, and we should be getting and we'll get an error. Invalid character, right? Because I know it looks weird. Like those are not the same character. Apparently not. It's weird with just how stuff gets rendered in a PDF. Sometimes the characters are a dash and not a minus sign. All right, 1, 2, 3. You can't multiply sequence non-int by type float. In other words, we can't take a string and multiply it against a float, but we put in a number. Yes, we put in numbers, but remember these are actually strings that we are typing in, right? Whenever you get input, it's a string, and then we got to try to convert it into our value. So I'm going to go ahead and say weight is equal to input. Oh, we're going to input it, and then we're going to change it into the appropriate type. Right? and we'll still get those errors because we need to fix the other ones, but that'll be fine for now. And remember, at the end, you want to make you don't want the BMR, you want actually how many chocolate bars you need to eat to maintain that BMR. Each, right? This is the number of calories, and a chocolate bar is 214 calories. All right, next one. Right, for this one, 2 parts. Def main and main are perfectly fine over here, right? The tabs were important. So the first thing is to figure out what the heck's going on over here. Get this to run because it's not going to run right now. Okay, it's not going to run right now, invalid characters, stuff like that. So get it to run first, and then fix the math error so that you get 12. So you get 139 when 12 is entered. Temperature. Again, this is an easier version of doing this. All right. Oh, and don't be scared with this one, with our temperature converter, temp con temp C2F. Right. For this one, you may get some issues where basically if you convert it, it might give you, if you put in 37, you might get 98.6. Right. You do the math, and you're depending on how you implement it, you might get 98.6 like this as your answer. That's fine. Don't worry about it. Rather than going over this one, I'm just going to kind of tell you these conversion ratio, these floats, okay? Double precision, floating point, right? This is the article if you want to know how all that works. This will tell you, this assumes you know a hell of a lot more than you actually do. But this is how it is represented. It's represented here in binary like this, where it's in basically a binary scientific notation with a sign, an exponent, and a fraction. It's actually pretty nifty. But as a result, trying to basically stuff all this decimal information into a binary number, it sometimes has quirks, right? So, for instance, what we're going to do over here is Python shell. What we're going to do is just show you by doing 0. Right? We do 1 plus 1.0 plus 2.0. This is probably the most famous example. 1.0 plus 2.0 is equal to 3.0. And 0.1 plus 0.2, right? That should be 0.3. But in actuality, we get this nonsense over here. And that's a little bit of error. There's tons of articles going over as to why this is. It's not important enough for our class to go over this. Just know that sometimes when we add doubles, it can be a bit imprecise, but the imprecision is such a level that we don't care. Okay? So, and finally, for this last one, right? Last one over here. Seconds to hours. Right? We've done this in class, so go ahead and do that one. Revert back to the lecture that I've uploaded. All right? And with that, I am going to go ahead and sign off.